Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of attributes of quadratic function graphs. This is standard A.7A in the great state of Texas, and we are using item number 34 of the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we are looking for the maximum value of g. We do have a graph we can use, and we have an interesting piece of information. The x-intercepts, the y-intercept, and the vertex are all integers. So let's find all of those, because one of those is basically going to be the answer that we're looking for here. So let's look at our x-intercepts first. And remember, our x-intercepts also go by other names. Sometimes we call them the zeros. Sometimes we call them the solutions. So they are the x value that make the f of x, or the y, become 0. So that's why we call them sometimes the zeros or the solutions. And they're integers, so now we don't have to guess whether it's, exactly on the line. Is it a 0.1, 0.2, 0.8, 0.9? So they're integers. So my x-intercepts are going to be right here. It's between 7 and 9. So my x-intercepts, or my zeros or solutions, are going to be 8. And then I've got one over here. Got a -4. So those are my x-intercepts slash zeros slash solutions. Y-intercept is going to be right where it intercepts the y-axis. It only does that one time, whereas for a lot of your problems, not all, but a lot, it intercepts the x-axis twice. So it looks like it's right there at the 8. Now, the y-intercept doesn't have any extra names like zeros or solutions, and so we'll just say the y-intercept, at least the y-coordinate of the y-intercept. If we wanted to plot the entire coordinate, right, we would say it's 0, 8. We would say these are 8, 0, and -4, 0. And that's it. Now, the vertex, right, is going to be right there. Since it's downward facing, it's the highest point, and then it's also kind of right on that the axis of symmetry. If we were to draw that, would kind of flow right through here. It's a symmetrical line, or symmetrical graph on either side of that. And that looks like it's going to be at 9, and it looks like it's going to be 2. All right, so x value 2, y value 9. Now, all of that kind of helps give us context. What are we looking for? We're looking for the maximum value of g. Now, this is the function g here. There is no g on here, but what we do sometimes is we'll say, all right, so our x value is our x, but on the y, it's actually g of x. And sometimes it's h of x, f of x, but it does tell us it's the quadratic function of g. So really, we're looking for what's the maximum y value. Now, if they would have asked us that, that would have made it a little bit easier, but we had to kind of figure out that this g is the g of x, since it's the function of g, which is measured by this y-axis. So what's the maximum value? Well, the highest that it can go is 9. And it can go infinitely below 9, but it can never go above 9 because that's the vertex. So when you're looking for the maximum value, look for the vertex, and that means you're going to have a downward facing. Sometimes you might get a minimum value. If it's a minimum value, also look for the vertex, but that means it's an upward facing or upward opening parabola. So that's it. The answer's 9. So we just need to bubble this in. Remember, we get a floating decimal. So you can really put it anywhere. I suggest putting all the way over on the right. You don't need a decimal or anything like that, so that's all we're going to do. We're literally just going to bubble in the 9, and that is our answer, because the maximum value of g in this graph of g of x is this y value of 9.